Dear all, welcome to the playlist of High Voltage Engineering. In this video, I'll be explaining high voltage testing on Surge Arrestor. Surge Arrestor is also known as Surge Diverters. So you can observe the real-time diagram of Surge Arrestors. It is also known as lightning arrestors. Let us understand how to perform high voltage testing on Surge Arrestors. Before moving on to the testing, let us understand the importance of surge arrestors or surge diverters. So, it is mainly used for the protection purpose. As you can see the typical diagram of surge arrestor, we have the power circuit. Our main aim is to protect the power circuit or electrical transmission line or any electrical apparatus. So, initially, we need to consider the components of surge arrestors. We have two major components. First one is spark gap. It is made up of spheres. And second one is we have non-linear resistors. It is not following Ohm's law. So these two segments comprises of the complete lightning arrestors, or you can call surge arrestor. It is totally cheap. It is not that much costly. Initially, the spark gap that will act as an open circuit. It won't conduct initially. Whenever high voltage surges are passing over the power line or high traveling wave with a very high magnitude that is contacting with the power circuit, at that time the high voltage will be generated over the spark gap. That means we are using the air as a dielectric medium. So dielectric breakdown will be taken place over the particular medium. As a result of dielectric breakdown, the spark gap gets conductive. There will be a building up of arc. That means the dielectric breakdown of the air that will be taken place over there. Because of that, the spark gap that will be conductive. The medium is getting conductive. Then it will be directly feeding towards the non-linear resistors. So it obeys the following characteristics. You can see the characteristics of a non-linear resistor. Here, as the voltage or current increases, resistance comes down. So whenever high voltage or high current is occurred over there, the value of non-linear resistor that comes down. It allows the high current or high voltage and it will be directly diverted towards the ground. That means traveling wave will be trapped and it will be directly feeding to the ground. Thus, you are ensuring the protection for power circuits. Power circuit in the sense it may be transmission line, it may be transformers or generators, whatever it may be. So it is ensuring the protection against traveling wave. So that's a peculiarity of surge arrestors. So case 1, it will act as an open circuit whenever no traveling wave or no surges are produced over there. It will act as an open circuit, no conduction. Case 2, the traveling wave that will be directly striking over the power circuit, so that you are supposed to protect the power lines, transmission lines or any other circuits or any other equipments. At that time, the breakdown will be taken place over there. That means air is a dielectric medium. The dielectric breakdown of air that will be taken place over there, so that the spark gap that will be conductive. Then it will be directly passed to the non-linear resistor. So the main function of non-linear resistor, as the current or voltage that is getting increased, we can say that the value of resistance comes down. That means current or voltage that is inversely proportional to the value of resistance. Then traveling wave will be directly trapped and that will be directly moved towards the ground, such a way that it ensures the protection over the power circuit. So if you are using earth screen or ground wires, you cannot able to trap this kind of traveling waves. You can able to trap some kind of direct lightning strokes, but you cannot able to trap this kind of traveling wave. That's the main problem. So otherwise you would have used earth screen or ground wires. This may not be necessary. But as far as the traveling wave or surge is concerned, the surge arrestor, or you can call lightning arrestor, that is mandatorily required. So this is the basic information about surge arrestor. Now let us do the high voltage testing on surge arrestor. So first and foremost thing, I'll be listing out what are the various testing which are applicable for surge arrestors. You can have the checklist of different type of testing procedure. First one is power frequency spark over test. Then 100% standard impulse spark over test. Then front of wave spark over test, residual voltage test, and finally high current impulse test on surge diverters. So these are the different methods of conduction of testing on surge arrestors. Let us study individual procedure. First and foremost thing, let me move on to power frequency spark over test. Regarding power frequency spark over test, it is actually mainly used for conduction of insulation portion of the surge arrestor. Whether the insulation or dielectric material has been provided over the surge arrestor is properly or not. Is it adequate or not? So that is the main purpose of conducting power frequency spark over test. So this is basically a routine test. So here, the arrestor has to withstand at least 1.5 times of rated value of the voltage for 5 consecutive times or 5 successive times. Okay, that means you need to apply 1.5 times of the rated voltage at least 5 times. For every application, your surge arrestor should withstand. Okay, there should not be any spark over or any other abnormality encountered. If if the circuit breaker or sorry, if the surge arrestor is said to be success or if you provided the insulation properly, then no spark over or no flash over should be taken place over the particular material. The test is generally done under dry and wet conditions. So these are the basic information about power frequency spark over test. The test is mainly implying or the test is mainly concentrating whether the insulation level is proper or not. Whether have you provided the insulation level proper on your surge arrestor? That is the main peculiarity of this type of testing. So this test is known as power frequency spark over test. We require the rated voltage and we have to apply 1.5 times of the rated voltage and you will be applying 5 times. At the each application, your surge arrestor should be survived. That's a peculiarity of power frequency spark over test. Now I'll be moving on the next type of testing. Let's have a brief discussion on 100% standard impulse spark over test. To conduct this test, we require impulse generator. So first and foremost thing you have to produce the impulse voltage and what you're supposed to do is you need to decide wavefront, wave tail, etc. Then successive 10 application you have to produce. You have to prepare for 10 applications. Okay, so at the power circuit you can see in the top side you can see the power circuit. With the help of impulse generator you will be producing this kind of impulse waveform. Then you will be applying directly to the power circuit. Now whenever you are applying each time the spark gap that will be conductive. The spark gap should be conducted. If the test is successful, each time the spark gap, you can see the spark gap that will be conducted. Then each cases the impulse waveform, that means that's some kind of traveling wave that will be directly feeding towards the ground. So I'll be applying 10 times. Make sure that each application, your spark gap should be conductive. That means there should be a flashover or puncture that should be taken place. Normally, if you are using air as a medium, definitely I should say that flashover should be taken place. Okay. So if the flashover is taking place for successive application, then I should say that your surge arrestor or surge diverters that is working properly. So this is regarding 100% standard impulse spark over test. One more important information, you have to apply for positive polarity and negative polarity waveforms because we cannot predict what type of traveling wave will be generated during lightning and thundering or during switching operation. So make sure that it will be applicable, it will be working for positive and negative polarity of waveforms. Then let me ask one question to you. Why it is known as 100% standard impulse spark over test? That means the magnitude of the voltage at which 100% flashover occurs is the required spark over voltage. That is why it is known as 100% standard impulse spark over test. So this is the basic information about 100% standard impulse spark over test. So we require one impulse generator. There will be designing the value of wavefront and wavetail as per the standard norms. Then you will be applying at least 10 times each and every application the spark gap should be operated. Then we can say that your surge arrestor will be perfectly alright. So this is regarding 100% standard impulse spark over test. Now I will be moving on the next procedure. I would like to discuss about front of wave spark over test. So for that purpose also we require the impulse generator. Here what you are supposed to do is you will be generating the steep front waveforms. With the help of impulse generator it is possible. Okay, that means it is having very high peak. And the specification of the test is given below. This test is conducted using over voltage having a rate of rise of 100 kV per microsecond. The voltage that is specified as 12 kV. Okay, so this is the specification of the test which is required. Anyway, we have to produce the steep fronted waveforms. That's a peculiarity. Okay, the test is done by conducting 100% spark over voltage test for increasing the magnitude of standard impulse waveform. Similarly, time to spark over will be measured and volt time characteristics has to be plotted. You are assuring that whenever you are applying steep fronted waveforms, your surge diverters will operate effectively. So that's the main peculiarity of conducting the test. You need to note down the specification, then you need to remember how you are going to produce steep fronted waveforms and what are the parameters you are going to take care, and what about the graph you are going to plot. So with the help of volt time curve, you can able to identify when the operation of surge arrestor will be taken place. So that is a peculiarity of front of wave spark over voltage. Now I would like to discuss about the residual voltage test. So residual voltage is nothing but you can observe the surge diverters or surge arrestor. We have two segments. First one is a spear gap, or we can call spark gap. The second segment is non-linear resistor. The voltage that come across that particular non-linear resistor, that is generally known as residual voltage. Here residual voltage will be taken into consideration. So let us explain how we can conduct residual voltage test and some mathematical analysis also there. So let us study the thumb rule for conducting the residual voltage test. So as you can see, this test is conducted on prorated diverters in the range of 3 to 12 kV. So these are the specification of the test. So we'll be conducting the test for the sample in between 3 to 12 kV. These are the voltage range of the particular diverter. The voltage developed across the non-linear resistor, short form we can call NLR, during the flow of surge current through the arrestor is called the residual voltage. Here the residual voltage is having most important to get the result. I'll tell you how to get the result, how to obtain the result. Standard impulse current of the rated magnitudes are applied. Okay, you will be applying the standard impulse current. Impulse current can be generated with the help of impulse current generator. You know what is impulse current generator? I already explained, but the design of impulse current generator. So basic information about the impulse current generator in the second module. And the voltage developed across the diverter is recorded. So you will be recording. So with the help you can use any kind of voltage divider. Especially you can go for capacitive type voltage divider. Then output of the capacitive voltage divider, that will be connected to DSO, or you can go for a cathode ray oscilloscope, digital storage oscilloscope, or you can go for cathode ray oscilloscope. Then you will be analyzing the particular waveforms. Regarding the procedure of conducting residual voltage test, the magnitude of the current, so we'll be generating the impulse current with the help of impulse current generator. The magnitude of current, that is approximately 0.5, then 1 and 2 times of the rated current. We are going to apply anyway you are producing the impulse current with the help of impulse current generator, and the magnitude you will be multiplying with the following factor 0.5, then that means half, then 1, that means the rated quantity, then twice, doubled, half, normal quantity and doubled. That will be applying that particular surge arrestor. From the oscillogram, a graph is drawn between current magnitude and the voltage developed across the diverter. So you will be plotting the graph. That means the current magnitude versus voltage developed across that non-linear resistor. So that you are going to take care. From the graph, the residual voltage corresponding to the exact rated current is obtained. Okay, you can do it from the particular graph. You will be plotting the graph. What are the things which are in the graph? That means current magnitude. Where you will get the current magnitude? It is from the impulse current generator. You will be applying 0.5 half times, then normal, then doubled. Okay, then you will be plotting the current versus voltage across that particular non-linear resistor. Then you will be plotting the graph. IV curve will be plotted. From the IV curve, the residual voltage corresponding to exact rated current will be decided. So let us consider the following parameters. Let V1 be the rating of the complete unit, and V2 be the rating of the prorated unit which is need to be tested. Let us consider VR1, that means residual voltage of the complete unit. The corresponding V1, we have to note down VR1. Then corresponding V2, that means we have to note down VR2, where VR2 is known as residual voltage of the prorated unit. So these are the 4 parameters we have to consider. Now we have to take care of the ratio. One important ratio will be there regarding the residual voltage test. That means V1 by V2 equal to VR1 by VR2. Okay, this relation you have to follow. So I already shown you that V1, V2, VR1 and VR2. You can take the ratio as follows. V1 by V2, that is equal to VR1 by VR2. Now you have to consider one factor that is known as multiplying factor. So let us understand what is a multiplying factor for the test. So VRM be the maximum permissible residual voltage. From the residual voltage we can take the peak value, that is VRM. Okay, for the complete unit. The ratio of VRM to V1. I already explained what is V1 and VRM. So VRM by V1, that is known as R, that is called multiplying factor. Okay, now when you will say that the diverter is completed the test successfully, so we can have one relation. When do you say that the surge arrestor which you are going to do the testing is successful after completion of residual voltage test? There is one thumb rule. Please note down the thumb rule. That means VR2. That should be less than R into V2. So R is known as the VRM divided by V1. That means the ratio, that is known as multiplying factor. That means VR2 should be less than multiplying factor times V2. Then we will say that your particular surge arrestor is perfectly alright. It works properly. So you can able to identify with the help of residual voltage. Residual voltage is nothing but the voltage that come across the non-linear resistor. So this analysis has to be done. Let us revise what I have explained. So as I was talking about residual voltage, initially I have specified the range of conduction of test, that is 3 to 12 kV. Then what is residual voltage I have explained. Then to conduct the test we require voltage divider. Typically capacitive potential divider is most suitable here, and we need a CRO to get the output. So what you are supposed to do is you will be applying the current in the range of half of the rated value, then rated value and double value of the rated value over your surge arrestor. Then you will be checking the voltage across the diverter and the current through the diverter, that you are going to check. And you will be plotting the curve and you will be noting down the following parameters such as V1, V2, VR1, VR2. Later on you will be taking one ratio V1 by V2, that is equal to VR1 by VR2. Later I have explained one thumb rule, that means one multiplying factor I have explained, VR1 upon V1, that you have to note down. From this relation I can able to make one thumb rule such a way that whether your surge arrestor is perfectly alright or not. If one relation, that means VR2 less than RV2, obviously I can say that your surge arrestor is following properly. It is working fine. It is efficient. Likewise, we can say it is safe. Okay. So this is regarding residual voltage test. Now I would like to discuss about high current impulse test on surge diverters. To conduct the test, we have three procedures that I will be discussing later. Three steps are there. Before that, I will be discussing the introduction part of high current impulse test on surge diverters. What are the general features of conducting high current impulse test on surge diverters? Anyway, we require impulse generator. Okay. The range of conduction of the test, that is in between 3 to 12 kV. That is the operating range of the test. Similarly, we need one impulse generator, and you have to produce impulse waveform in the range of wave front equal to 4 microsecond and wave tail is equal to 10 microsecond. Wave front equal to 4 microseconds and wave tail equal to 10 microsecond. That means I have mentioned as 4 bar 10 microsecond. 4 belongs to wave front, 4 microsecond belongs to wave front, and 10 microsecond belongs to wave tail. Then you need to apply the at least two application has to be made. That means two such applications are done on the units under the test. Okay, the allowing sufficient time for cooling of the unit to the room temperature. At least you have to prepare for two application. Successive two application has to be done. So impulse waveform having the range, that means 4 bar 10 microsecond. At least you have to go for two such applications. Then after two application, you have to make some conclusion. What are the conclusion to be made? The unit said to be perfect. That means unit in the sense the surge diverters is perfect if it follows the precautions or following points. If it satisfy the following thumb rule, following checklist. Because anyway you will be generating impulse current with the help of impulse current generator. I have mentioned the specification as well. That means 4 bar 10 microseconds. Okay, then at least you will be performing two consecutive or two successive applications. Okay, from the successive two applications, you are going to make some inference. If your surge diverters is perfectly alright, if your surge diverters surge arrestor is active or healthy, then the following things should be followed. First one is the power frequency spark over voltage before and after the test should not differ by more than 10%. That's a first point. Moving on to second point. The voltage and current waveforms of the diverters do not differ significantly in the two applications. That is also one of the most important parameter. Moving on to third parameter, the nonlinear resistance elements in the diverters do not show any sign of puncture or external flashover. Whatever the nonlinear resistor NLR you are using, that should not show any damage. I mean either puncture or flashover. Anyway, we can talk about, it's a solid material, we can talk about puncture. Normally we may not predict about flashover. Okay, so if three results are obtaining, then we can say that your surge diverters is perfectly alright. Your lightning arrestor or surge diverters is okay. So far, high current impulse test on surge diverters is concerned, you have to check the three conditions. It should satisfy these three conditions. Okay, then we can say that your surge arrestor or surge diverters is perfectly alright. Now let us discuss the three sub procedures for conducting high current impulse test. So we have the checklist. The first one is known as long duration impulse current test. Second one is known as operating duty cycle test, and third one is other test. These are the three sub procedures comes under high current impulse test on surge diverters. Let us have a brief discussion individually. First and foremost thing, let me move on to long duration impulse current test. The specification I have mentioned, that means for the Pro unit, you will be doing the test in the voltage range of 3 to 12 kV. This is a voltage range. Anyway, we require impulse generator. That means you can go for rectangular impulse generator circuit you can follow. I have explained the video on how to produce rectangular impulse waveform with the help of impulse generator. That I already explained. You can visit my playlist of high voltage engineering. You will be getting that particular video. You can refer first. I have done the simulation also. The circuit used for generating a rectangular impulse waveform consisting of an artificial transmission line with lumped inductance and capacitance. First, you have to consider one equivalent circuit. Okay, so anyway, we require impulse generator. That impulse generator speciality is it produce typical rectangular pulse. We have to consider the particular equivalent circuit. In that, we will be having a transmission line and we will be having inductance and capacitance. Okay, that we have to consider. That reactance part you have to consider. The duration of the current pulse T that you can calculate with the help of one formula. There is a formula you can able to calculate the duration, that is T is given by 2 into n minus 1 into root of LC, where n is the number of stages. How many number of stages you are going to use that particular rectangular impulse current generator, where L and C are inductance and capacitance. Okay, so that you are supposed to note down. So this is the value of duration. You can able to calculate the duration by using the formula. Similarly, you can able to calculate the surge impedance. If you take the ratio of square root of L by C, you are able to get the surge impedance. Similarly, that rectangular pulse you have to apply for 20 times. For your surge diverters, at least you have to go for 20 times. The interval between each successive application is at least 1 minute. Okay, 20 application has to be made and the duration of application is at least 1 minute gap or 60 seconds. What you are supposed to do is, you have to record the waveform also. At least what you can do is, first 2 and last 2 attempts you have to record. Anyway, you will be applying 20 times. At least the first 2 times and last 2 times you should be recorded the waveform. You can use the potential divider for your convenience. Capacitive type potential divider is most viable for this application, especially regarding the impulse waveforms and all. Capacitive type potential divider is most viable solution. Then you can use DSO or CRO and you can record at least the first 2 and last 2 attempts. Then study the particular waveforms. Now we have to consider the specification. Then you will be considering one rectangular pulse. Then duration you are supposed to take care. Then surge impedance you are supposed to take. Then how many times you are going to apply. At least 20 times you will be applying, and the duration that is equal to 1 minute gap. Then you will be applying you will be considering first 2 and last 2 application, and same thing will be recorded. That is important. Now we have to make some inference. What are the conditions if the surge arrestors clear all the test? I mean, what are the conditions if your surge arrestors perform well? Or suppose the diverter is said to have passed, then it should follow the following results. It should give the following results. What are the results? Number 1, the power frequency spark over voltage before and after the application of the current wave does not vary or does not differ by 10%. Second point is, the voltage across diverters at the first and last application does not differ by more than 8%. Anyway, you will be taking care first 2 application and last 2 application. It does not differ, at least it should less than 8%. If it is more than 8%, then you can say that the test piece is not good. You can reject your surge arrestor. That will not perform better. There is no sign of puncture or damage, especially on the non-linear resistor. So these are the 3 results. You have to verify that your surge diverter should pass these particular result. Okay, you'll be getting the positive result. It should follow the following sequence. So you have to assure the following 3 conditions regarding long duration impulse current test. I have explained how to calculate the T, how to calculate surge impedance, all the things I have explained. Now I would like to discuss the second procedure regarding high current impulse test on such diverters, that is known as operating duty cycle test. So let us discuss the procedures regarding operating duty cycle test. This test is conducted on prorated units of diverters and gives better closeness to the actual conditions. So this test is mainly checking the correctness, the perfectness of your surge diverters regarding its operation. The diverter is kept energized at its rated power frequency supply voltage. So that's the first thing you have to do. The rated impulse current waveform is applied the first phase angle about 30° from the AC voltage 0. So this phase difference you have to take care. Almost 30° phase difference you are going to maintain. Now the current wave is applied in the advanced step of 10° and up to it should be conducted up to 90°. So you have to make at least 20 applications and maintain the gap of 1 minute or 60 seconds. You have to maintain the gap and you have to check each and every hour. Okay. Now you have to check the following result. That means if your surge arrestor holds good, if your surge arrestor gives better performance, it should clear all 4 steps. The first step is the average power frequency spark over voltage before and after the test does not differ by more than 10%. Number 1. Second procedure or second result, the second criteria, the residual voltage at the rated current does not vary more than 10%. You have to correct the spelling. This is does. The residual voltage at the rated current does not vary more than 10%. You have to use does. Okay, spelling is somewhat wrong. You have to change. The follow on power frequency current is interrupted at each time. That you have to take care. One more important thing. No puncture or flashover regarding the nonlinear resistor or any other unit. If 4 criteria are satisfied, then you can say that the operating duty cycle test is successful for your surge diverters and your surge diverters is healthy and perfectly alright. Okay, this is the second type of testing regarding high current impulse test. Okay, here what you are supposed to do is you are changing the phase angle and this is mainly used for correctness of your checking the correctness of your surge diverters and the phase angle I have mentioned here. Then how many applications? There are 20 applications and the gap of application is at least 1 minute. Then you are supposed to make the following observations. Now let us discuss about the third criteria, that means other test. What are the other tests need to be conducted? The following tests which are applicable and we will be calling other tests. Number 1, mechanical test like porosity test, temperature cycle test, or you can call temperature rise test and other type of test. Then pressure relief test, that is also important, pressure relief test. Then voltage withstand test on the insulator housing of the diverter, basically insulation testing. Then switching surge flashover test, that is also comes under insulation test. Finally, pollution test. These are the different categories which are comes under other type of test. This is also belong to high current impulse test on surge diverters. Mainly these 5 criteria that is applicable for extra high lines. Whenever your surge diverters is operating for extra high voltage transmission lines or extra high voltage devices, this test should be followed. Other than that is not required. Okay, if you are operating, if your devices or transmission lines are operating under EHV systems, you have to follow these systems. You have to follow these procedures, testing procedures. Otherwise, you can go for the previous ones only. Okay. So these are my references. I have gathered all the information with the help of the following textbooks and some website which I mentioned at the beginning. So let us conclude the session. Right from the beginning, I have explained the importance of surge arrestor. Why surge arrestor is required? What is the importance? Okay, what are the necessity of surge arrestor? How does it operate? And what are the speciality of nonlinear resistor? Why nonlinear resistors are required? These are the basic information you need to know before explaining the different type of testing. So that's the first part which I explained to you. Later on, I have explained the various testing procedures of surge arrestors. Do remember, surge arrestor is also known as lightning arrestor or you can call surge diverters. Don't get confused. So these are the 5 procedure which are comes under high voltage testing on surge arrestors. In that high current impulse test on surge diverters, there are 3 sub procedures. That is also I have explained. Finally, thank you very much for watching this video.